Hello, fellow Physics 40B students. My name is Scott Medchin, and today I'll be going over problem number 1 for week 7. This question asks you to explain why the specific heat at a constant pressure and the specific heat at a constant volume for an ideal gas are related by a shift by the gas constant R. They also ask in part B to briefly explain why the specific heat at a constant pressure is larger than at a constant volume. Um, Pretend that you can't see this part, but anything below this yet. This graph is going to be really helpful for this problem. Basically, it shows a process of some gas on a process A that is a constant volume process or isochoric, and a process B that is a constant pressure process or iso. Uh, this one's iso. I'm sorry. The constant volume process is isochoric, and the constant volume process is isobaric. Sorry if I messed that up. Anyways, what's unique about this interpretation here, or this graph, is that it actually shows you quite nicely that, oh, this process from I to F, or initial to final, in both of these processes, they start at one isotherm and they end at the same, or they end at the same isotherm. So if that's the case, then they must have the same change in temperature. Okay, okay, so if they have the same change in temperature, then that also means that they have to have the same change in thermal energy. So that leads you to the conclusion, oh wow, then that means that these two things are equal. And that's where you really get going in this problem. After that, there's some substitutions that are made with work and this equation, and eventually with the PV equals nRT equation and some deltas. And basically what ends up happening if you substitute in this PV equals nRT equation is that um, the delta goes over, and since the pressure is constant in the constant pressure process, it only goes to the volume, and there's only a change in temperature here because obviously N and R are constants. So then what ends up happening is T cancels out and N cancels out everywhere. And then you're left with negative R plus specific heat pressure is equal to specific heat volume. And then you rewrite that a little bit and you end up getting this, which means that the specific heat at constant pressure is equal to the specific heat at constant volume plus a shift in the gas constant R. So that's like super cool. And yeah. For B, the simplest example, or the simplest solution I can give is from the book actually. It says here that the heat required to bring about the temperature change depends on what the process is. An isobaric process, or one that relies on pr pressure, requires more heat than an isochoric process, or one that relies on volume only. So that means that to get the same temperature change while holding pressure constant, you need more energy. And if you need more energy for that pressure uh, constant, then this Cp needs to be greater than the Cv. So that's why that you need more energy when it's a constant pressure process than when it's a constant volume process. That's just how it is. You just need more energy for that. Um, so that would be the solution part B, and then part A is kind of all that stuff. So yeah, thank you for listening, and I hope that was informative. Yeah.